Okay, here's the data that we just looked at in the last video, but now I'm going to show you how to do this on the computer. First of all, I'm just going to take a little detour, show you a histogram. Notice I can do both frequency or relative frequency histogram on Statcrunch. I can overlay a normal distribution. I can mark the mean. And there's all sorts of other options, but let me go ahead and just hit compute. And it gives me, this is kind of normal, but I wouldn't call, I wouldn't, this is a little bit not spread out to be normal. There's not much in the tails. But you can definitely see the histogram. You can see the mean is 10. It tells us the standard deviation is 1.8257. But which standard deviation is that giving us, the sample or the population? So let me show you how to do this just for the calculation. I would go to Summary Stats, Columns, and for population, I'm going to go to, first of all, I'm going to select variable 1, for population, it's the unadjusted variance and unadjusted standard deviation. And for the sample, it's just the variance and standard deviation. So we have sigma squared, sigma, S squared, and S. And you can see that on my chart here, it's giving me the sample mean and the sample standard deviation as opposed to the population mean and population standard deviation. Okay, we're going to compare some data here. So first of all, I have 3 sets of data, and I'm just going to we have it variable 1, variable 2, and variable 3. I'm going to graph these in histograms so we can see what they look like. Let's see, we'll just do a frequency histogram, and I want to see the mean for all of these. Okay, so here's the first one. Here's variable 1. It looks like the means, well, there we go. It's about 10.44, and it's definitely right skewed data. So, and we can see that we have, most of the values are piled up on the left, and then we have a long tail on the right there. The next one is a little bit more normally shaped, a little bit not quite symmetric, but a little bit more symmetric. And but it's definitely piled up toward the middle, and even with the data here, we can see that there's a lot of 10s and not too many stragglers there. So this one's very bizarre. It should be a uniform distribution. There are 2 7s, 2 8s, 2 9s, 2 11s, etc. But you can think of it as normal, uniformly distributed between 7 and 15 here. They should be about all the same height, and we have, let's see, the mean here is 11. Okay, but we're not looking here necessarily for the mean. I want to ask about standard deviation. What do you think the standard deviation is, or the spread is, for each of these variables, variable 1, 2, and 3, and which one is the highest? So remember, the standard deviation is the average distance each value is from the mean. So which one do you think has the highest one? Well, I would say that the variable 2 has the lowest standard deviation, and that is because the scores are all piled up in the center mostly, and then there's just a few that are outside of it. So on average, let's say how far is each value from 10.33? Well, most of them around to 10.33. We have a couple of around 8, 9. So that's a difference of 1 or 2 units, and then a difference of a couple of units on the other end. So I would definitely say that the standard deviation would be less than 2. However, let's look at the next one. The next one, I would say, would be in the middle, because they're definitely more spread out. They're not all piled up in the middle. They're evenly spread out, in fact. And so I would say that this is the middle, if I were putting them in order, middle standard deviation. That leaves the first graph, or the first variable, to have the highest standard deviation. But that's kind of annoying just to sort of like put them in order. And so I can actually calculate the standard deviations by just going to Summary Stats, Columns. I'm going to click on 1, 2, and 3. I'll assume that these are samples, and I'll calculate the end mean and variance and standard deviation for all three of these. So let's see here. Variable 1 definitely had the highest variance, and taking the square root of that, highest standard deviation. Variable 2 had the lowest variance and the lowest standard deviation. Variable 3 had the middle, and we can see those in actual numbers here as well. And it makes sense here if you kind of look at our values that for variable 1, we're expecting approximately that every variable is that each value is approximately 4 units on average away from the mean, whereas here it's just less than 2 units away from the mean, and here it's on average it's over 2 units away from the mean.